Alrighty, today I'm going to be going through polar and rectangular representation of a sine wave. I'm going to be super quick with this one. So mathematical expression for a sine wave is just given here. I'm giving you an example here, phi being the amplitude, and that is the range from zero either way. This W form here being how many times the wavelength forms within 360 or 2 pi. Given radians, and then this theta here is how much offset it is from zero, and I'm just given zero here for this example. That's typically given in radians, but I'm using degrees for this example. Polar and rectangular form is basically two representations of the same value. Polar form is a vector using magnitude and direction being angle from the x-axis. But to use this in mathematical equations, a much easier sense, we're going to be converting it to rectangular form. To do that, we'll keep moving on. So we have that mathematical representation of a sine wave just here. If we have been given this and say a question, that's easy. We can just grab these two values here, and then this is our representation of polar form. This is always given in degrees, I believe. Alrighty, then to convert from this to rectangular form, first thing we need to do is convert to RMS values. And now quickly what an RMS value is just if we have this area under the curve, say if this amplitude isn't 170 but is 20, if we have this area under this curve here, then the RMS value is just going to be the area given in a rectangle or a square. It makes the calculations a bit easier. Converting from polar to rectangular, so we're doing this RMS value conversion first, which is just the amplitude divided by √2. Then finding the real value by the amplitude RMS multiplied by cos theta, or angle, and then the imaginary value by the same equation, but converting cos for sine. Now this gives us a rectangular form of one real and one imaginary value, and that's added together like this, j being a negative of a root. As seen in Maths 141 if you have completed that. This is our rectangular expression I said here. To convert it back, what we're going to be doing is doing Pythagoras' theorem. This gives us the RMS as we saw previously. Then all you have to do is multiply that by √2 to give you the amplitude seen here. To find the angle, it's inverse tan, imaginary over real, similar to finding the resultant force vector in engineering subjects last semester, and we're back to this here. I'll give you this summary. This is just what I've just gone through, but a bit more simplified, and this should help you guys convert between them much easier.